In this talk, we're going to have a look at architectural design. In particular, we're going to start in the process of taking our game idea and breaking it up into a number of probably large, but nonetheless component parts. And if we put all those parts together, then we'll actually bring to life our game. So it's an important first step in taking something that is large and complex, and games are a large and complex piece of software, and making it a little bit more manageable, something that we can actually ultimately develop within code. So the first part, we're going to look at some of the principles behind it. In the second part, we'll have a look at an example game. So we'll start off looking at some of the key components within 2D games in this particular case. If we are thinking about developing an architecture of something, it almost goes without saying that there's something that we have in mind, that there's some commonalities, there's something that constitutes what it is that makes it a game. And we want to try to tease out, well, what do games have? What different components do they comprise? And doing that, we then know the types of things that we're going to probably have to include in our own game development. So we'll start off with an exercise first of all, and really would suggest or recommend that you actually do this. So whenever we introduce it, pause the video or the PowerPoint and actually spend 5 or 10 minutes doing this here. It will actually be useful by way of helping in your mind bring together some of the things that we're going to be talking about. So the challenge, if you like, is to select a game genre, any one you want. Over on the right hand side you've got some examples, so I'm suggesting things like a platform game or a racing game or a rhythm game. They're all reasonably easy examples to use of genre. Some of the more difficult ones, maybe things like adventure games or puzzle games. So take whatever genre you want and think about, well, let's imagine 4 or 5 or 6, as many instances of that particular genre as you can, so ones that you've played. And ask yourself, well, what do they have in common? What features or characteristics do they have that enables you to look at maybe one you haven't seen before and to say, oh, that's a platformer. Now, in doing that, what we're interested in teasing out is some of those common aspects, and in terms of what do most of these games have. And by doing that, we can then select for your own particular project, okay, well then maybe we should have this or we should have that in by way of the basic structure of it. So certainly please do have a bit of an exploring attempt at doing this. Once you've done it, and I assume that, okay, you've had a chance to think about that, I'm going to have here my own abstracted version, and it's not specific to any genre. Instead, I'm going to make a bold claim that for most, not all, but for most 2D games, these are the types of things that we will have within them. And it's not presented in terms of the most obvious first, but we'll show the whole list and then we'll go over it. So 2 games, they have front ends, so they have menu systems or splash screens. They have assets. So if we're talking about a game, most games have graphics. Now, it could be an animation, it could be some static images. Most games have sound effects or have some background music. Games almost certainly comprise objects. Now, this could be the objects that you have actually within the game itself that bring it to life, your sprites, or it could be other fixed ones like platforms. It could be HUD, head-up display elements like a score or a countdown or something related to that. The objects, they also reside within something. So when we're talking about playing a game, we're talking about a map or a level that sort of transitions or as a way of recording the transitions through it. So our objects live within some type of container or description of some sort. And finally, we have input events. So a game is an interactive experience. So other than our graphics and our sound, we also are interested in getting input in from the user. Things most 2D games do, well, they, once per game or per level, they are concerned about loading in the graphics and the sounds that they will need. They're concerned about actually creating the world, the level, the map that all of these objects mostly reside within, and that's really the building our basic objects and then populating the containers with those objects. Lots of times each second, So when we're doing a game, we have a main loop that is updating and drawing, and talking about the number of frames per second. It could be 30 or 50 or 60 frames per second. For each of these frames, we're considering, well, has the player provided us with any input? We're going to our objects and we're saying, well, how do you want to update yourself? I'm asking them then to draw themselves and to play any sounds that they need to do. So a bit at the bottom is important. There is no correct answer to this. Instead, this is an attempt. You can have your own attempt as well at some of the common features or aspects or things that we have within 2D games in particular. And it's important to start that process because, as mentioned, the game is a large piece of software, and we will have to start breaking it up into smaller bits if we're to have any hope of actually being able to finally implement this. But this is an important initial step. So, having identified then some of the features that we have within it, let's see if we can piece these things together into what we could call or define as an architecture. So we'll have a look at it. It's going to be in the abstract, so it is very abstract. This will set a very broad picture. Ideally, you should be then developing your own more refined one for your particular development. Now, we're assuming that we'll be doing an object-oriented design. So when we talk about the objects that we have within the games, we mean objects in the object-oriented sense. And certainly you could imagine the game playing in your head, which is a good thing to do. You could imagine, okay, here I have a character or an object within the game. If we're looking at implementing a coded version of that, then we want to look at good solid principles like abstraction and encapsulation. So what defines, what properties should that game object have? And that could be anything from things like its position on the screen or in the world to the assets, the sounds and the images that it uses. You also want to think for each of your objects, well, what do they do? What functionality do they have? Do they just sit there and do nothing? Is there a bit of AI behind them and they interact in some way? How are they drawn? And it's those fundamental questions asked of each of the objects that will enable us to model an object within our game. Alongside thinking about what defines an object, we also want to think about, well, how are these objects related to other objects, either through inheritance or through other aspects like composition. So in other words, if I have my health pickup, where does it live? What is it, a part of a collection? Do I group it together with the other health pickups? Is it just part of the level? Is it within an inheritance hierarchy? Do I have a wider range of things that can be picked up, and this is just one refined type of it? And what other objects does it need to communicate with? So maybe it needs to communicate with the player or with anything else. So there's some of the fundamental questions that enable us to start that process of refining the objects that we have within our game. Grouping all this together, then we can come to this first very high-level, hand-wavy overview. So if we're thinking about modeling our particular game, what we will have is as follows. We'll think about our game in terms of the objects that we have within the game. That's the right point to start at. For each of those objects, we want to say, well, what type of object is it? What properties do we think that object will have? What functionality do we think it will have? At the start, it's going to be virtually impossible to specify this 100% accurately, but it doesn't have to be. As long as you're getting something down by way of your initial design, that is good enough. It gives you an initial stab at creating the object. And over time, you can tweak the properties, you can tweak the functionality as needed. But certainly you'll want to think about the objects within your game, and then for each of those, think about, well, what defines it? What properties, what functionality should it have? Objects, as mentioned, they also tend to be grouped together. Maybe, as mentioned, that it could be a collection of all of our health pickups. Maybe it's just the objects that reside within a particular level. But certainly within the game, we also want then to think about the groupings that we are likely to have, because this will enable us then to group together these objects into coherent wholes. Finally, but not least, we also want to think about how these objects will interact with one another. Some objects are likely to interact with lots of other objects. Then again, we can also have some objects just sit there on their own, don't interact with anything. But it is continuing this process of taking an idea for something within our head of how we think it would play and breaking it up into a structure that lends itself to be implemented within code. So this is the process of decomposition, taking a complex activity and chopping it up into smaller, more manageable components. The final thing we have here, sorry, before I go on to the final thing here, just to mention that if we were to take all of these objects together and all of the properties that they have at a particular point in time, that's known as the game state at an instance in time. And for every single iteration of our loop where we update and draw things, we're updating the game state. So just a little bit of a side on that. So finally, these objects that we're creating, they themselves will be interacting through APIs with the device on which we're running the game. So they may be loading things from the file system, checking for user input, displaying graphics, displaying sound. So this is where we have our interaction to the actual device in which we're running. Okay, so high-level design, but nonetheless, hopefully a starting point whereby you can take your game idea and try to break it up into smaller, as mentioned, more manageable pieces. So here's a slightly related view on the previous slide. We've mentioned that central to the game is our update draw loop. That if we're running at, say, 50 frames a second, it means that 50 times a second, we will go around our objects and ask them to update themselves. So for example, looking for input from the user or running some AI routine. Also 50 times per second, we're going to be asking the object to draw itself to the screen and to reflect any changes that it has. So this notion of the loop continually running underpins basically all of our games. So if we have a bunch of objects, let's have a look at how we can sequence or structure that within the context of the view of a game loop. So over the right hand side, we still have our objects, which we've defined to have their properties and their functionalities. We're grouping those within containers. And at the very start we mentioned about the notion of a level or a map or something along those layers. Here I'm just calling it as a layer within the game. So we will have different layers. We could have one for the first level, one for the next level. We could have a separate layer for the menu screen. Whenever we build a level or a layer, we are constructing the objects that reside within that particular layer. And then we will have an update and we'll have a draw method. So this assumes that each layer, each container can update and can render, can draw the objects that reside within that particular layer. In turn, we also have our main game engine, the main game loop. And here, whenever the constructor here kicks off, I'm assuming here, we load in whatever assets we need to load in, so loading things in from our images or sounds, and we build the containers. So here we might build a container for our front end, we might build another container for the first level, and that's enough to get us up and going. And we have our run loop, where we are looping forever, where we're going to say, okay, what are the active layers, the ones that are currently visible? Let's update those and let's draw those. So again, this is another slice through, this time looking at who drives change in terms of update and draw from the central game loop. Useful way of doing, because it gives us an opportunity to group or to define or to view the game as a number of different layers, which in turn contain related objects within them. So it's all part of this process of divide and conquer. Finally, well, not finally in this slide, but another one as well at the top for input events. The things that interact with all of these here. So we may be loading in our assets or images within the main game, but it'll be the objects, the characters that'll be using those assets in terms of how they are displayed, or the types of sounds that they're playing. Equally, in terms of input events, really anything could consume an input event. It may be within the game engine, if there's a console, all the way down to the objects looking at some input from the player. So these collections, we mentioned that our objects are stored within some type of collection, a map, a level, a layer, or just general container. There's lots of different data structures that we can use to store our objects within. And you can see a few of them here in terms of a fixed array, or dynamically resized array, or a hash map, or a linked list. To a certain extent, all of these objects, all of the containers have, or are fundamentally the same in terms of the functionality that they offer. They let you add objects to them, they let you take objects out of them, they let you get objects either in terms of a particular index or at a particular named value within it. So how do they differ? They differ really in terms of the speed with which they do this. Some data structures are incredibly quick for getting a particular indexed value, but are then quite slow for inserting or deleting objects. Other ones, it's very easy to add or to remove, but it's not that fast to retrieve a value from it. Now, within your data structures and algorithms module, you'll be looking at these in a lot more detail. For this one here, suffice to say, all we need to do is we want to pick a collection that offers the right level of performance for how we think it's going to be used. So if you think we will be frequently adding and removing things to it, then pick a data structure that's good for that. If you think it's going to be largely fixed and getting quick access is more important, then pick a data structure appropriate for that one. We've also talked about the notion of updating our objects, and we said here we could have a particular layer. The layer contains a number of different objects. We've got a couple of options about how we might go about updating them. One is centralized control, where we have the container or the layer which contains the objects deciding how all of the objects that it contains get to be updated. Now, the benefit of that is it's very easy to coordinate behavior between objects. If we have a whole bunch of objects that are flying about on the screen, then if we have the update within the layer in which they live, it's easy for that process to coordinate the movement and motion between them. The downside is that this all works fine if everything gets to be updated in more or less the same way, but if we have different objects that need to be updated in different ways, then very quickly it gets cumbersome to include all of these different variants within our main update process. The counterbalance to centralized control is decentralized control. In this case, each object itself has its own update method and gets to determine how it itself is updated. The advantage of this is that you can very easily have each object do its own thing. No issues at all. But the counterbalance to that is that if these objects need to communicate with one another or to coordinate their behavior, then it's generally more difficult and challenging to achieve that. Now, good news is you can use them both. You don't have to pick one or the other. It is perfectly fine to have a level with some centralized update, does the common bits, and then pushes out each of the objects for their own decentralized update just by letting them do their own thing. So you can mix and match these two models as you wish to. Other aspects, so we're sort of going through the game and how it'll play and looking at some of the things that we'll want to keep in mind when we're thinking about developing our game. Doing things in the right order also comes into it. So if we have a game with a couple of different layers and maybe those layers contain a couple of hundred objects and we want to update them and to draw them, it is actually going to be important to think about, well, which object gets to be updated first, which object gets to be drawn first. We just don't pick them at random. We'll probably want to have a little bit of control over that. So let's look at drawing first of all. We've got a screenshot here. It says that in 2D games it can be important to make sure you draw things in the right order, certainly if we want to have the appearance of depth and consistency from one frame to the next. So you might, as you can see example here, we've got the castle wall and it's drawn in front of the background scenery. So it means that we would need to have drawn the background first of all, and then on top of that to draw the castle wall. If we look at the player, we'll see that the player would be in front of the background and in front of the castle wall, but is behind the rope bridge. So when we're drawing this, we're sort of layering it up one layer at a time. For a HUD then, that's drawn on top of everything. So that would be the last thing that we would have drawn. Drawing's fairly straightforward. Yes, we do need to have things in the right order, but often for updating, there's a logical sequence within which we would want to update our objects. So for example, we might want to, first of all, check to see if we have any collisions. Has anything collided within the game? Then to take an action based on that, and then to update things like the score, the last roll in the frame overall. So depending on your game, you will want to think about, okay, I've got a bunch of objects, I want to update, I want to draw them. In which order should I do that? So key takeaways. It has been a lot of ground covered within this here. So we'll go through the takeaways and we'll summarize up first of all. So I'm suggesting for each of your games, you should sit down in your teams and go through and think about what are the key objects. Doesn't matter if you don't get all of them, just pick the core ones. Could be interactive, could be informative, could be decorative. Once you've taken those, ask what properties does it have? How do you update the thing? How do you draw the thing? And how are you actually going to define that particular object? And also ask, how are these objects related? How are they grouped together? And you can follow that through into then looking in more detail about the update process, the sequence in which it's done. So all of the stuff we covered today really is, it genuinely is quite important for each team to actually sit down, probably spend a couple of hours, and to have an initial stab at doing this for your game idea. It takes a large nebulous idea, a game concept, and breaks it up into a number of smaller components. You won't be able to, probably won't be able to do it with remarkable precision in the first one. That's fine, doesn't matter. What your goal is to get a better feel for how the game splits up. And you want to iterate and refine that process until you've got lots of different bits and you're down to a level where you think, you know what, I could probably have a stab at implementing this class or implementing this type of behavior. And that's the right level to break your design down to, the point where it becomes easier to see what the underlying code has to do to map onto the game. The theory is that if you then do this, you take each of the bits, you implement the code, your game emerges and comes together. And it's as simple as that, or at least in principle. In the next lecture after this, we're going to have a look at one example of game. It's actually going to be Space Invaders. And we'll have a little look at how we can define objects there, how we can sequence things within our update loop. So thank you.